Hello students, welcome to the channel of Vedant classes. Okay, so in this lecture we'll start with class 10 physics and we'll start with the chapter number 10, that is light. This is very important chapter of class 10 in science. Okay, so let's start this chapter with an introduction. So let's give the heading introduction. Okay, now let's make a first point that light is an electromagnetic radiation. Okay, so this is the very basic thing, that light is an electromagnetic radiation. So light is a part of electromagnetic radiation. We are having the electromagnetic spectrum. Okay, so light is a part of that which causes the sensation in eye and which helps the people to see the world, or you can say which helps the organism to see the world. Okay, now light is having dual nature. Light behaves as a both, you can say particle nature, light is having a particle nature, or light is having a wave nature. Okay, so this is a contradiction. Till now it is not proved that light is having specifically which kind of nature. So practically light is considered as both, as particle nature as well as wave nature. In particle nature it is considered as a single particle, and in wave nature it is considered as a wave. Okay, so it is travel in the form of wave. Okay, so now see, in the ray optics, the light, this topic belongs to the ray optics, and in ray optics we consider the light as a particle nature. Okay, so we'll consider that light travels in a straight line. Okay, so this is an important assumption to learn this topic, that light always travel in a straight line. Okay, now let's see the speed of light. Speed of light in vacuum. So speed of light in vacuum, it is noted as c. Okay, and its value is 3 into 10 raised to 8 meter per second. Meter per second is the unit for speed of light. Okay, unit for the speed, and in other terms you can write it as 3 into 10 raised to power 5 kilometer per second, or you can say 3 into 10 raised to 10 centimeter per second. So in other terms you can remember it like this. Okay, so but most important one is this one, that is SI unit. Speed of light in vacuum is 3 into 10 raised to 8 meter per second. Okay, let's make the other point, that is range of wavelength of visible light. Okay, now you can also make point here that we are considering light as visible light. So this visible light belongs to the electromagnetic spectrum, that what we have written in the first point. Okay, so range of wavelength of visible light. Visible light in the electromagnetic spectrum, that for an example you can say in your screen. So that is an electromagnetic spectrum, and in that, just beside the ultraviolet radiation and infrared radiation, in between those two you can see the visible light. Okay, so the wavelength for the visible light is 4 into 10 raised to minus 7 meter to 8 into 10 raised to minus 7 meter. So this is the range of wavelength for the visible light. In other terms you can remember it like this. Okay, in terms of nanometer, see 1 nanometer is equal to 10 raised to minus 9 meter. So in that terms it is 400 nanometer to 800 nanometer. This is the range in terms of nanometer. Then in terms of angstrom, that is written as A and dot over the A. So 1 angstrom is equal to 10 raised to minus 10 meter. So in that terms you can write it as 4000 angstrom to 8000 angstrom. So this is how you can simply convert the different units. These all are the questions that can be asked in the exam. So remember this important point. Okay. Now let's see what is ray. Okay, what is ray in terms of physics. Now ray is a thin line in direction of propagation of light that is emitted from source. Okay, if the source is there, let's say here we are having the bulb, that is source of light. So a single thin line that emitted and shows the direction of propagation of light, so that is known as ray. This is known as ray. Okay. Now what is beam? The beam is collection of ray. So collection of ray is called beam. If you are having parallel rays like this, then this is known as beam. Okay, so this is known as beam. Take a screenshot of this one, so we'll proceed further. Okay, now let's see the next topic, that is of image. Okay, so remember that minimum 2 light rays are required to get an image. Okay, so minimum of 2 light rays are required to get an image. If you want an image, then you required minimum of 2 rays. Okay, now in that, first is real image. First is real image. When 2 light rays intersects, okay, when 2 light rays actually intersects, then you will get real image. Okay, when 2 light rays intersects, you will get real image. Okay, remember this point, real image is obtained on screen. So whenever you are having screen word in physics, it means that you are obtaining real image. Okay, second is virtual image. Okay, virtual image. So when 2 light rays does not intersect, then you will get virtual image. Okay, so this image cannot be obtained on screen. You cannot obtain the virtual image on screen. Virtual image are those images that you can see in the plane mirror. The image formed in the plane mirror are always virtual image. Okay, now let's see the next one, that is reflection. What is reflection? So let's define the reflection. That is the name of the chapter. Okay, so you can define the reflection like when light rays travels back in same medium after gets incident at any point on the surface. If the light ray reflects back in same medium, okay, travels back in the same medium, then it is called reflection. If it travels in the other medium, then it is called refraction. That we will learn in the latter part of this chapter. Okay, so this is how you can understand the reflection. Okay, so now let's see the important one, types of reflection. So let's see the two different types of reflection. You might have learned this topic in your lower class. Okay, so first is regular reflection. Okay, so in regular reflection you can say that when parallel incident rays remains parallel after reflection, then it is called regular reflection. So when parallel incident rays remains parallel after reflection, then it will called regular reflection. Okay, so regular reflection generally occurs on the smooth surface, and the best example of smooth surface is plane mirror. Okay, so plane mirror is the best example for the smooth surface. So remember this example. Okay, let's understand it using a diagram. Let's say here we are having a any smooth surface. Let's say we are having any smooth surface, and here this is our incident light. Okay, so it reflect like this. This is another. This is third one. It reflect like this. Okay, so you can see that here this parallel incident rays are remains parallel after the reflection. So such type of reflection are called regular reflection. Okay, now let's understand the next one, that is irregular reflection. Okay, irregular reflection is also called as diffused reflection. Okay, it is also known as diffused reflection. So in that, one word that you need to change, that parallel incident rays do not remain parallel after reflection. Okay, so when parallel incident rays does not remain parallel after reflection, then it is called irregular reflection. So let's write its definition. When parallel incident rays does not remain parallel after reflection. Okay, so it is known as irregular reflection. Irregular reflection occurs in, you can say, rough surface. It is observed in rough surface. Okay, the examples of rough surfaces are, you can consider any, let's say, book, then chair, table. So these all are you can say irregular surfaces, or you can say rough surfaces. At microscopic level, when you observe this surface, and it will be somewhat like this. Okay, so here it is a reflecting surface and it is rough in nature, it is not a smooth like this. So when incident on this surface, when parallel incident ray incident on this surface, it might reflect like this, and it will reflect like this will reflect like this. So you can say there that reflection pattern is not parallel in this case, and such type of reflection are known as diffused reflection. Okay, so take a screenshot of this one so we can move ahead. Okay, okay, now let's see the laws of reflection. It is very easy and IMP topic. Okay, laws of reflection. Now let's consider one surface like this. This is, let's say, a surface we are having. Okay, and let's consider the incident light is incident on the surface and at this point. Okay, So let's say we are having one line like this, let name it as n dash. Okay, so after reflecting from this point, let's say the line is moving like this, the light travels like this. So here let's give it the name P, here Q, here R. Okay, you can give the name, and this n dash. So now let write all the terms. See here PQ is your incident ray, QR will be reflected ray, here n dash will be normal to the surface, okay, at point of incidence, and here Q, point Q, it is called point of incidence, and it will be on surface. Okay, now see the incident light, this is our incident ray, this is our incident ray, this is our normal ray, and this is our reflected ray. Okay, so the angle between the incident ray and normal ray, let mark it as theta I. Okay, so it means that theta I, it is our angle of, it is called as angle of incidence, it is called angle of incidence, and it will be between incident ray and normal, it will be between incident ray and normal. Okay, now see the angle forming between normal and reflected ray, let mark it as theta R. So this is angle of refraction, reflection, sorry. Okay, so this will be between reflected ray and normal, so this is known as angle of reflection. Okay, so now let write the laws. So first law is the angle of incidence is equal to the angle of reflection. Okay, it will be true for any surface, either regular or irregular surface. The angle of incidence is always equal to the angle of reflection. So therefore you can say that theta I will always be equal to theta R. Okay, so this is true for any surface. The second law is incident ray, then a normal ray, normal, you can say normal at the point of incidence, and the reflected ray, all lie in the same plane. Okay, so it means that all these three rays, incident ray, reflected ray and normal, all lie in a same vertical plane. Okay, you can consider it like this. Let's say this is the incident ray, okay, and this is the reflected ray. So you can see that both these lie in a same vertical plane. If I put the reflected ray like this, then it means that this is out of the plane. So this incident ray is inside the plane, but reflected ray is moving out of the plane, and such type of situation never occurs. Okay, so that is the reason you can consider both in the same plane. Okay, in a same vertical plane, both the light rays, all the three light rays lie, that is incident ray, normal and the reflected ray. Okay, now make important note which will be helpful for you while solving the questions. Okay, first is always consider theta I and theta R with normal. Okay, So it is very important that you should consider the theta and theta r in the angle between. See, the definition itself says that angle of incidence is the angle between incident ray and normal, and the angle of reflection is the angle between reflected ray and normal. So you always must make the angle with reference to normal and not with the surface. If it is given with the surface, then you can transfer the angle, okay, because you can see it is a 90 degree. Normal will always be at the right angle with respect to the surface, okay. So you can say then angle with surface plus angle with normal, that will always be equal to 90 degree. You can see that angle with normal and angle with surface, the sum of both will give you the right angle, okay. Then one important note, that when light is incident normally, it means that when light itself incident at the 90 degree, so at that time there will be no angle formed with reference to theta I with reference to normal. It means that when light is incident normally, you have to consider theta I is equal to theta r, and that will be equal to 0 degree, okay. Because now let's say that if light is incident here, so we are considering the angle with normal as theta I. If light is incident as like this, so there is no angle forming between the incident line and normal, and again the light will, as the theta is 0, so according to laws of reflection, as theta is 0, theta r will also be 0, okay. So remember these key points, it will be helpful for you, okay. So that's it from this lecture. Please like, subscribe and share the channel if you are really finding it helpful, you are enjoying the learning here in this platform, okay. So if you are having any doubts regarding this, then you can mention your doubts in the comment section, okay. So keep working hard, enjoy the physics, keep learning. Thanks a lot.